We live in the age of innovation. Smarter phones, brighter TVs, thinner laptops, all promising improvements. But this constant upgrade cycle comes with growing piles of electronic waste. Devices are designed for replacement, not repair. In 2020 alone, the world generated over 53 million metric tons of e-waste. That's more than all commercial airliners ever built. Most of this waste isn't recycled. About 80% is disguised as donations to countries ill-equipped to handle it. Toxic materials like lead, mercury, and cadmium leach into soil and water, or are released into the air when burned. We're exporting our environmental problems, creating pollution that devastates communities far from where the devices were used. The valuable metals inside are locked within hazardous substances, making recovery dangerous and expensive. The cycle of constant consumption and disposal poisons land, water, and air, leaving a legacy of pollution. The sleek devices we love have a very ugly afterlife, with recycling nearly impossible. Our appetite for new technology is fueling a global crisis. The true cost of our gadgets is paid by people and places we rarely see. The problem is bigger than just devices piling up, a complex global chain of harm. Discarded electronics often end up sprawling in scrapyards in developing nations, fueling a dangerous recycling industry. People dismantle gadgets manually, using hazardous methods to extract tiny amounts of valuable metals. Burning cables and open-pit acid baths expose workers to toxic fumes and corrosive chemicals with little to no protection. Children are often preferred for their small hands, working long hours surrounded by over 1,000 harmful substances. Lead, mercury, and flame retardants cause severe health problems, developmental issues, neurological damage, cancer. The most vulnerable people risk their health for a meager living, with no oversight or safety regulations. About 3/4 of the world's e-waste disappears into this unregulated system, far from the stores where these products began. The devices that symbolize progress become instruments of disease and exploitation. The human cost of our throwaway culture is immense and largely invisible. Our demand for the latest tech is paid for by those with the least power to protect themselves. The true price of innovation is measured in lives and health, not just dollars. Faced with this crisis, scientists are exploring biodegradable electronics, devices designed to break down naturally, leaving no toxic trace. Imagine a smartphone that dissolves after use, returning safely to the earth. The goal is to replace plastics and toxic materials with organic, compostable alternatives like cellulose, silk, and chitosan. Researchers are developing organic semiconductors and electrodes, rethinking every layer of device construction. Manufacturing shifts from energy-intensive to solution-based methods, like printing circuits onto flexible, natural substrates. These advances could create electronics that transform into harmless components when composted. The vision is radical technology that serves its purpose, then vanishes without a trace. But can these innovations scale to meet the demands of our tech-hungry world? Biodegradable electronics emerge claiming real-world impacts in medicine and environmental science. In medicine, dissolvable sensors can monitor healing inside the body, then safely disappear. No second surgery required. Environmental scientists deploy biodegradable sensors to monitor soil and water, gathering data without leaving pollution behind. These niche applications are genuinely sustainable, solving specific problems with minimal impact. But mainstream devices like phones and laptops remain out of reach. Organic materials can't yet match the performance or durability of traditional components. Biodegradable tech is promising, but not a solution for the huge stacks of consumer e-waste. The gap between lab breakthroughs and everyday gadgets is still wide. For now, the biggest benefits are in temporary uses, and fully compostable smartphones are still a distant dream. The challenge is scaling up without sacrificing function or sustainability. The promise of biodegradable tech brings a risk, guilt-free consumption. If we believe our gadgets will simply vanish, what incentive is there to repair or keep them longer? Biodegradable electronics could fuel an even more extreme throwaway culture, accelerating resource depletion and energy use. The core problem isn't just materials, it's our relentless appetite for new devices. Marketing green gadgets as disposable could make us feel virtuous while increasing our environmental footprint. True sustainability means valuing longevity, repair, and mindful consumption, not just managing waste. Technology alone can't fix a problem rooted in human behavior. Without a shift in habits, biodegradable tech risks becoming a greenwashed excuse for more waste. Biodegradable electronics sound safe, but the reality is complex and risky. New materials, especially in batteries, bring unknown hazards. Fires, explosions, and toxic leaks are real possibilities. Most consumers won't realize that biodegradable doesn't mean every part is harmless or compostable at home. Batteries and some components still require careful disposal, and improper handling can negate any environmental benefit. Devices could degrade prematurely if exposed to heat or humidity, causing malfunctions or even medical emergencies. The challenge is to create materials stable in use but degradable on command, a difficult balance. Without clear guidelines and public awareness, these risks could outweigh the benefits. The knowledge gap is dangerous. Eco-labels can lull us into complacency. We're only beginning to understand the potential failures and hazards of these new materials. Responsible innovation demands transparency and caution, not just optimism. Biodegradable electronics are only as green as the systems that support them. Without proper collection and disposal infrastructure, these devices could worsen environmental problems. Tossed into landfills, biodegradable materials may release methane, a potent greenhouse gas, rather than composting cleanly. Mixed with traditional recycling, they can contaminate entire batches, undermining existing e-waste systems. The lack of public education and clear disposal streams could create chaos, not solutions. Stripped of batteries, biodegradable husks may still pollute soil and water with unknown byproducts. We have no long-term data on how these materials affect ecosystems. Without robust infrastructure and education, well-intentioned solutions can backfire. Good intentions alone won't solve the problem, they could make it worse. We stand at a crossroads. Biodegradable electronics showcase hope for a sustainable future. In medicine and science, they're already making a difference, but scaling up brings real dangers. Marketing these products as guilt-free is misleading. No single technology can absolve us of responsibility. The real solution lies in building global infrastructure, investing in public education, and designing products for easy, safe disposal. Without these systems, biodegradable tech is a liability, not a solution. True sustainability means rethinking our relationship with technology, reducing, repairing, and reusing, not just replacing. Innovation is powerful, but not a magic fix. We must pair new materials with education, infrastructure, and shared responsibility. The future depends on more than invention. It depends on how we choose to use and value what we create. The path forward is clear: combine innovation with responsibility, or risk repeating the mistakes of the past.